UAV that we used for this last project was a little bit larger one than this one. It's a 6-blade. This is Mike Gimmel. He's one of the TAMs for Autodesk. He's got a lot of experience flying these things, and I think he said the larger you get, the harder they are to fly. But this is about an $8,000 rig. He mounts a GoPro camera for his visual, so he's got a monitor that shows him his actual flight, where he's flying at that time, and where the camera that's mounted below it, which he uses an Olympus SLR, DSLR, to take the pictures. Great images that came out of here. The quality that you get from a DSLR over, say, a GoPro, to me is double or triple the quality. So the higher quality camera you use, the higher the quality of the results that you're going to get. The sharper the images, the sharper the meshes. So there's a lot of science that goes in between what kind of lens that you have versus the type of pictures that you take. This is one of the projects we did. This was actually done from an airplane and a basic DSLR. One of the guys leaned out the side of an airplane, just a biplane, and took a couple of images around this facility down at John Deere. And this is actually a textured mesh. It's not a picture, it's a textured mesh. And this is the mesh. So this is about 1 million square feet. So John Deere normally has laser scanners that come out and scan these facilities, both ground-based and roof-based. This would probably take, just for the exterior, probably take 6 or 7 days, plus some data processing for a scanner if you wanted to get high detail. The accuracy is not quite what a laser scanner would be, but if you were to get a couple of survey points in here, you could probably dial that down to about 1 inch, 1.5 inches. So depending on what you're actually looking out of, 1.5 inches is pretty darn close for the amount of data that you're getting out of here. You're getting all the bays, all the roof units, quite a bit of data just in 45 minutes this took to actually do this. They published the pictures up on Recap 360. It was 1.5 hours before they got a textured mesh and a point cloud back. So out of Recap R360, which is Recap 360, they exported out. You can export out an RCM, which is a Recap mesh, OBJ, RCS, all point clouds and meshes that can be opened in any of our softwares, as well as competitive softwares. So we're not binding you to our software format. So surveying, not to leave them out. I know we got a couple of them here. We've got quite a few uses. Our new technology on the survey side. New technology for surveyors is, we're getting higher speed returns on survey equipment. We can actually scan with survey equipment now, which is quite a bit different than years before. We were just, taking single points or single shots. So with some of our softwares, including Navisworks and AutoCAD and Revit, we can export out points that can be read directly into the total station. And then results can be fed back into any of those softwares to get analysis. Slab analysis, we can pinpoint hangers where they need to be, or walk pieces of equipment into place. So if we had a total station on site and we had data from the master model, we can actually walk a piece of equipment into place, which is pretty impressive. Usually you'd put something in place and then you'd measure it. This is something we can walk into place and get direct feedback from the model. The kinematic scanner that we were talking about earlier, this is a picture of the space that we scanned just recently. So a nice empty space is ideal. We had an empty warehouse, which is surprising. All the equipment, most of the equipment had been removed. There was still some machinery sitting around. But you see on here, this is R2D2. Or what was that guy's name? Johnny 5, yeah. So Johnny 5 sitting here. This has the GPS unit sitting on top. So we started with GPS outside, acquired a signal, and then put a corner cube on there and picked it up with a total station. So as soon as we were inside, we dropped the beam on it. The total station from the surveyor picks it up, and we just took paths and walked through the building. And with the new total stations that are out there, you can actually walk across the beams and break the beam, and the total station will pick it back up automatically. So we're walking behind objects up to 7 seconds. You can walk behind it before it reacquires, and it scans as you go. So it's pretty quick. It's very accurate. the total station really brings the accuracy level to something very acceptable for architectural use. I think we were, Chad, 6 millimeter accuracy?
Yep, sure,
okay.
Absolutely.
So,
whatever the scanner is.
quarter of an inch is very acceptable when it comes to architectural use in my eyes. If you're trying to route piping through anything architectural, it's spot on. So the basic how it's used. Total station set up outside. We usually set a grid if we need to. We can also tie into local coordinates within the building, which would be like your drawing, or you can set up to global units. And again, it shoots right at the total station as you walk through. So that's all I got. Told you everything I know. I'd answer questions, but I don't know anything else. So, anybody got anything? No? Crickets?
How big was the site that you captured with that technology?
With the mobile scanner?
Yeah.
We told them it was 1 million square feet, but it was actually 1.4 million square feet for that area. But 1,000,004 square feet in just a couple of days. So it was very quick. That site, we did have all that technology. We had Faro scanners on site, Leica P20, the linear scanner, which is 7,000, the drone, and a total station, all within that 6 month or 6 week period of time, where we were doing different types of tasks. There's not, I don't believe that there's one scanner for every type of job. You don't bring a linear scanner out to scan a car. You bring a white light scanner out. So we mixed and matched depending on the task that we were looking for and the outcome, the time that we had available on site. So the linear scanner fit when we were trying to get quick, fast data that we didn't need the panoramic pictures out of. So there's a lot of factors that went into deciding which ones that we used on which job.
What I thought was really unique, all the different types of data that was used to capture this facility that size, and it all went together into one recap file is your deliverable, which is pretty impressive. Right? And that can be shared with any other software we talked about today. And more.
So the logistics of, or the legal things about using the drones, is there a, hey, we're just going to throw in the roof scan for free, but the rest you're going to have to pay for?
So the workaround for that is flying is free. Engineering and alignment is at a paid cost. So there's a way around. It's just you can't charge for flying right now.
Don't brag about it too much. Don't put it in their face too much. Keep it low key.
Yeah, hey, I made $100,000 off of flying a job, and you made $100,000 maybe off of engineering, but not for flying. So way around. It's a really cool technology. You can see how fast it captures a site. As long as you can, handle that accuracy decrease. And we got a lot of laser scanning guys and surveyors in here that have been working hard to bring that accuracy down to a manageable number. And manageable is something 6 millimeters, 4, 2, 1 millimeter accuracy. We get so crazy and stuck on an accuracy that we don't realize that we're routing a 4-foot pipe through a 12-foot hole. Do we really need to be within 2 millimeters? Probably not. So that's how I try and think about things, is what's the accuracy, and then I match it with a tool. It all comes down to the cost for the customer. If they don't need to spend $200,000 on something that we can do for 40, then we should probably go with the lower cost, because at the end of the day, you'll get more jobs.